This is the practice assessment for the Chapter 4 test. Remember, problems on this test are very similar to the ones on the actual test. In problem number 1, we want to know if the following values are zeros of the polynomial a cubed minus 3a squared minus 3a minus 4. There are two ways of going about determining if these two are zeros. One way, or the simplest way, is to actually just plug the number in and determine if the output is 0. This was called the remainder theorem. If you plug in a number that you suspect is a 0 and the remainder is 0, then it's a 0. Another way of doing this problem is to graph it in your calculator, the polynomial, and see if the graph touches the x-axis at either of those points. A third way of doing the problem is synthetic division. If you put the number you're checking in the box and next to it you put the coefficients of the polynomial and you perform synthetic division, if the remainder is 0, then it's a 0 of the polynomial. I'm going to do the actual algebraic methods. If you want to check on the calculator, you may do so. So in part A, if I plug in 4 everywhere I see an A, I find out it's 0. So the answer is yes, 4 is a 0. In part B, in order to do synthetic division, I write the one below the line, and then I multiply it by -2 and write that number above the line, and then I add going down. And then I multiply that number with the number in the box to get the next number above the line, and then I add going down. And then I multiply that number with the number in the box, and then I add going down, and I get -18. I couldn't fit it in my box. So the remainder is -18, which means that -2 is not a 0. In number 2, we're going to use the quadratic formula in order to solve these two quadratics. The quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. In problem A is 5, b is -1, and c is 10. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I like to simplify this problem in parts. So this is 1. The discriminant, the part under the radical, is -199 all over 10. Since I have a negative under the square root sign, the answers are complex, they're imaginary, and 199 can't really be simplified. So the final answer is going to be 1 plus or minus I, the square root of 199 over 10. Now let's go do this again in part B. In order to use the quadratic formula, your equation has to equal 0. So if it does not equal 0, make it equal to 0 first. So I'm going to subtract 4. A is 2, B is -7, C is -4. Now I'm going to plug it into the quadratic formula. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So I get +7 plus or minus the square root of 81 all over 4. And the nice thing here is that the square root of 81 is 9, so I get 7 plus or minus 9 over 4. So one of my answers is 7 plus 9 over 4. That's 16 over 4, which is 4. And the other answer is 7 minus 9 over 4, which is -2 over 4, which is -1/2. In order to use synthetic division to determine whether a binomial is a factor, I'm going to take the binomial that I think is a factor, set it equal to 0, solve for x. That number goes in my box. Next to the box go the coefficients of the polynomial, 1, -1, -10, -8. Don't forget to ask yourself if there are any missing terms, because if you have any missing terms in the polynomial, you need to put zeros in their places. All right, so I bring down the 1. Above the line is -2. Below is -3. Above is +6. Below is -4. Above is 8. And below is 0, and the remainder is 0. So yes, it is a binomial factor. As a matter of fact, if you were to graph the original polynomial and check and see if -2 is an x-intercept, you would find out it is. In part B, first I'm going to set that equal to 0, solve for x, so x is 5. 5 goes in my box. The coefficients are 2, -5, 7, and 1. 2 goes below the line, then 10, 5, 25, 32. Oh boy, now I got to do some multiplying in my head here. Let's see, 160. Let's see, 5 times 2 is 10, and 5 times 3 is, yeah, it's 100. And then this is 161. Since the remainder is not 0, this is not a binomial factor. As a matter of fact, if you were to graph this in your calculator, the graph does not cross the x-axis at x equals 5. If I want to find the zeros of a polynomial, a lot of times the easiest way to do it is to graph it in our calculator and find the zeros on it. So I'm going to put in y1 equals 4x cubed plus x squared minus 11x plus 3. And don't forget to make y2 equal to 0, because we're going to find where our polynomial intersects the x-axis. So here's the graph that I get. Now, although it looks like this hits at -2, if you go to the table function, you'll see that at -2, the output is not 0. So we're going to use the intersect function, second trace 5. Move your cursor around that 0, hit enter 3 times, and it's going to tell you that that 0 is x equals -1.90. The one in the middle, second trace 5, I'm going to move my cursor closer to the one in the middle before I hit enter 3 times, and I'm going to find out that the one in the middle is x equals 0.29. And now let's go find this 0. I'm going to move my cursor closer to it before I hit enter 3 times. We're going to find out it's at 1.36. The best thing to do when you're writing these decimals is round them to the nearest hundredth. In number 5, it says, between what consecutive integers are there zeros based on the table? Remember I mentioned that we know that the graph is going to cross the x-axis when you're looking at the y values, and the y values change sign. So I want you to notice that the y values here go from negative to positive, and then here from positive to negative, and then again over here. So this particular polynomial would cross the x-axis between -3 and -2, and again between -2 and -1, and would cross again between 1 and 2. For problem number 6, although I'm going to do this problem algebraically, you are more than welcome to do it on your graphing calculator the way I showed you. The first denominator factors into n plus 1, n minus 1. And then, because the next two denominators are n minus 1 and n plus 1, this is going to be my least common denominator. So the first fraction is not missing anything. But the second fraction is missing an n plus 1. And notice that I wrote this in parentheses because we're going to have to distribute. And the third fraction is missing n minus 1. So first what I'm going to do is I'm going to distribute these, and I get 2n squared minus 3n minus 5, and we double check my work because I did it quickly. 2n squared plus 2n minus 5n would be negative 3n. And then I'm going to distribute these, and I get 2n squared. Let's see, minus 2n plus 5n is going to be plus 3n minus 5. Since this is quadratic, in order to solve it, I'm going to make one side of the equation equal to 0. Well, the nice thing is, look at what's going to happen to the squares. Yay, they're going to cancel. However, the linear terms are not going to cancel. So this is now going to be 0. These cancel and these cancel. I'm left with 10 minus 6n equals 0. So negative 6n is going to equal negative 10. So n is going to equal 10 over 6, positive 10 over 6, because the two negatives cancel, which reduces to 5 over 3. 5 over 3 does not make any of the original denominators 0. In problem number 7, since I have two fractions equal to each other, the best way to solve this problem is to cross multiply. So I would get 9b minus 27 is equal to 3b plus 15. And then I'm going to subtract 3b, so I get 6b minus 27 equals 15. I'm going to add 27, and I get 6b is equal to 42. So b equals 8. And 8 does not make either of the denominators equal to 0. Remember, in order to solve radical equations, we want to first isolate the radical, if you can. You can't always, but if you can, you do. Again, I'm going to do these two problems algebraically, even though you may choose to do them on your graphing calculator. So in problem number 8, I have to subtract 8 first. So I get the cubed root of x plus 2 is equal to negative 4. Remember, cubes, or any other odd root, can give you negative answers. So now I'm going to square both, not square, I'm going to cube both sides. Cube, cube. And I'm left with x plus 2 is equal to negative 64. So x is equal to negative 66. If you check negative 66, you should get that as the answer. Number 9. In order to isolate the radical, the first thing I'm going to have to do is subtract the 5. This problem's a little harder because there are x's on both sides, but at least I isolated the radical, and I'm ready to square both sides because I'm getting rid of a square root. So the left-hand side, when you multiply x minus 5 times x minus 5, is going to give you x squared minus 10x plus 25. And the right-hand side is going to be x plus 7 because they cancel. Now I'm going to get this to be an equation equal to 0. And I get x squared minus 11x plus 18. And this one is a simple factor because x squared minus 11x plus 18 factors into x minus 9, x minus 2. So x is equal to 9 and 2. I'm still going to double check to make sure those answers work. So my first question is 9 equal to the square root of 9 plus 7 plus 5? So 9 is equal to the square root of 16 plus 5. 9 is equal to 4 plus 5, which it is, so 9 works. Is 2 equal to the square root of 2 plus 7 plus 5? 2 is equal to the square root of 9 plus 5. 2 is equal to 3 plus 5. 2 is not equal to 8. So it turns out that 2 is an extraneous solution, and 9 is the only answer. The last problem, what power is the polynomial that goes with the table below? Remember that we're going to go into our stat edit and put this into list 1 and this into list 2. this is the graph that I get after I put the data into list 1 and list 2, and then hit zoom 9. Remember that the stat plot needs to be turned on in order to do this. So if your stat plot is not on, go to second y equals, enter, enter to turn it on. Now, this is kind of up for debate because maybe it looks like the graph does this, and it has 3 changes in direction. So if it has 3 changes in direction, we might think it's x to the 4th. I'd be more inclined, though, to think that it's actually a cubic function because this one seems to be an outlier. I don't know if it is, but I would be more inclined to think that there are only 2 changes in direction, in which case it's x cubed. So if I decide that it's a cubic function, when I go do my cubic regression, the equation I'm going to get is y is equal to negative 0.13x cubed plus 0.31x squared plus 2.70x minus 2.42. And those are the solutions to the practice assessment for the Chapter 4 test.